right, what is up, guys? Mr. Rushka here with our 3.7 notes. All right, so thank you for bearing with me and going back to video lectures at home, even though you don't like it. Just how life's got to be right now, unfortunately. All right, so let's dive right into these notes on graphing linear inequalities. Okay, first one right here, part A. Our inequality is y is less than x. Y is less than x, okay? So here's how these work, okay? What you're going to do when you're graphing inequalities is first, you're going to graph it just like if it were an equation. So graph just like an equation, okay? All right, so if this were, if my inequality right here were instead y equals x, right? How would we graph that, right? Well, we do graph our y-intercept, which is technically 0. So 0, 0. Let me do that. I'm going to do that in pink. All right. And then our slope is technically 1 right there, right? So we're going to graph that, okay, as if it were just the line y equals x, okay? All right. So we got that. Don't forget my arrows, okay? All right, okay, so we'll graph that line. One thing I have to mention here, guys, if I have y is less than x here, I have y is less than x, okay? Okay, since it's less than and not less than or equal to, my line here actually needs to be dashed. I'm not going to have a solid line. I'm going to have a dashed line, okay? So I'm going to have a dashed line. Okay, so let's do dashed line. Can you do that on here? Ah, here we go. Let's do that. All right, so we're gonna have a dashed line instead, right? So let's make note of that real quick, okay? So less than and greater than get dashed lines when we graph, right? Okay. And my less than or equal to and greater than or equal to get solid lines when we graph, just like regular equations. Okay. All right, and then my second step, so we're done graphing our line. My second step is to shade. Shade. Either left or right, or above / below. All right, so we have y is less than x. Y is less than x right here, okay? So because our little alligator mouth here, like our little alligator is eating our x, we want our x to be greater, so we're going to shade more to the right because x is greater as we go to the right. So we're going to shade to the right here. Let me use a yellow highlighter. Is that okay? So we're going to shade everything to the right. And then we're done. We're done with this problem, okay? We shaded to the right because we want y to be less than x. We want x to be greater, okay? Y gets greater as we go up. We don't want to go up, right? If we had shaded on the left side of this dashed line, that would mean we're going above the dashed line. We're getting too big on y. So we shaded to the right of the dashed line because that's where x gets really big. X gets bigger as we go to the right, okay? That's example 1. Example 1, all right, there in the books, okay? Let's move this a little bit out of the way of the second problem. Yep, okay, good. All right, so same deal, okay? We're going to graph this. We have y is less than or equal to minus x minus 3. So we're going to graph that just as if it were y equals minus x minus 3. And then notice because I have a less than or equal to symbol here, that I'm going to get a solid line when I graph, okay? So let's graph this in pink again. We want a solid line because we have a less than or equal to. My y-intercept here is 0, -3. Okay, my y-intercept, my slope here is -1. Slope is -1, so let's do that. Okay, that's my slope. All right. And we want y to be less than or equal to minus negative x minus 3. Okay? Want y to be less than or equal to negative x minus 3. So here's all the points. This line is all the points where y is equal to negative x minus 3. This is all the line is all the points where y is equal to negative x minus 3. It's on this line, okay? We want y to be less than this line. We want it to be less than that line, okay? We want it to be less than that line. So we're going to shade to below that line for this one, okay? So let's do that. Oh, I want a highlighter. There we go. We want to shade below. Okay? So y is less than or equal to negative x minus 3 here, okay? Right, if you didn't understand that, go rewind, email me, ask questions, ask Mr. Miller questions, okay? Why? We want our line to be, our shade below the line, because y is less than this line, okay? Part C, same deal here, okay? So we're going to solve this. We're going to graph it just like it's a line, okay? Just like it's an equation. So let's do that, right? Let's graph, let's get this in slope-intercept form first, okay? So what does that mean? It means we get y by itself. So we're going to start with x plus 2y is greater than negative 2. We're going to get y by itself, so we're going to subtract x from both sides. 2y is greater than negative 2 minus x. And then let's divide by 2 on both sides. That gives us y is greater than negative 1 minus 1/2 x. Okay? And then we're going to graph this almost exactly as if it were the line y equals negative 1 minus 1/2 x. Note, though, that the only difference, since we have a greater than, it's a greater than symbol and not a greater than or equal to. Since it's just a greater than, we have to use a dashed line. So let me get the dashed line function going here, okay? So I'm going to graph the point. Negative 1 is my y-intercept. So let me graph my y-intercept, okay? And then my slope is negative 1/2. So I'm going to go, what is that, over 2, down 1. So right here. And then I'm going to graph the line through those points. Okay, keep going. Right, and I'm using my dashed line. This is super nice. All right, okay. So I'm using my dashed line, okay? Right, and now let's look at my inequality here. So let's highlight that. It's important to pay attention. Oh, gosh, that's important to pay attention to this. Okay. It's y is, so this is the line. This line is where y equals negative 1/2 minus 1/2 x. That's where these two are equal. We want y to be greater than that. We want y to be greater than this line. So we got to go above the line and shade that line, okay? Oh, shade above the line, sorry. Okay. So we're going to shade above the line, okay? Here, fill it in, fill it in, fill it in, fill it in. There we go. All right. Part C in the books. In the books. Same thing here, D, okay? We're going to solve this for y, put it in slope-intercept form, right? We like our slope-intercept form. Okay. So add 2x to both sides. Okay, get that out of the way. Negative 5y is greater than or equal to 10 plus 2x. Divide by negative 5, divide by negative 5. We get y is greater than or equal to negative 2 minus 2/5 x. Okay, here's my inequality here. I'm going to graph this with a solid line since my symbol is greater than or equal to. Okay, so I'm going to graph this just as if it were the line y equals negative 2 minus 2/5 x. Okay, how would I do that? We're going to use a solid line, solid pink line. Okay, good. Let's graph my y-intercept, which is 0, negative 2. There we go. And then for my slope is negative 2/5, so my second point is going to be down 2 to the right 5. There we go. Okay. Right, down 2 to the right 5. Yeah, that's good. All right, cool. There we go. There we go. There we go. So there's my line. let's see where I'm going to shade, okay? So this line, this is the line where y equals -2 minus 2/5 x. We need y to be greater than or equal to this line. So we're going to shade above the line because y increases as we go up. So let's do that real quick. Oh, what's going on? There we go. There we go. D in the books. In the books. Okay, so pause, rewind, hit like the cog button on YouTube, play it like half speed if you're having trouble. Okay, so let's go down to part E. Part E, all right. Same thing, slope-intercept form, okay? So let's get y by itself. So we have 2x is less than -3y. We're going to divide both sides by -3. Okay, guys, remember, right? When I do that, when I divide by negative on both sides in an inequality, I got to flip my inequality symbol. So it's going to be -2/3 x is greater than y, okay? We flipped it around. We had to flip my inequality symbol, okay? Since we divided by negative, all right? So we're going to graph this just as if it were the line -2/3 x equals y, right? We're going to do it just as if it were that line. But remember, our symbol here is just greater than. It's not greater than or equal to. It's just -2/3 x is greater than y. So we have to graph it with a dashed line. Okay? All right. So let's graph this, right? My y-intercept is 0, 0. Right, my slope is -2/3, so down 2 to the right 3. And I'm going to draw my dashed line through those 2 points. There we go. Okay. Let's look at my inequality here. Let's look at my inequality. -2/3 x is greater than y. So here's the line where y is equal to -2/3 x. Now we need, let's flip around this inequality. We need to have y be less than -2/3 x. We need y to be less than that line. So we're going to shade below the line. Below the line, okay? There we go. Let's fill her in. There we go. Got it. Okay. It's part E in the books. Part F. Y is less than or equal to 2, right? This one you can't get in slope-intercept form, but that shouldn't be too much of a problem because we should remember from the last chapter, the last test, that this is the same as graphing the line y equals 2, and that's, right, we're going to use a solid line. We're going to have a solid line because we have y is less than or equal to 2. So we're going to graph this literally exactly like it's the line y equals 2. Oh, that's y equals -2, sorry. Y equals +2 up here. All right, and we want y. Let's look at our inequality here. Y is less than or equal to 2. So this is the line where y equals 2. This is the line where y equals 2. We want to shade all the y's that are less than 2. So below that line, okay? So ask Mr. Miller for help. Pause, rewind if you're not understanding. Okay. So that's part F in the books. It's part F in the books, okay? All right. Okay, so this one for part 2, this is analogous to our compound inequalities from the chapter 2.5 through 2.7 test. Okay, so we're going to just graph these one at a time, these inequalities one at a time, and then we're going to shade the overlap. I guess you'll see in an example. So let's start with x is less than or equal to 2. So let's highlight that. That's the one we're going to work on first. So we're going to graph that just as if this were the line x equals 2. Okay, and we're going to do that with a solid line because it's a less than or equal to 2. So let's do solid pink. Actually, I'm going to do solid blue. Okay, so this is the line where x equals 2, okay? We want x to be less than or equal to 2, so we're going to go to the left here, because as we go to the left, x gets smaller, and x is going to be less than or equal to 2. So let's shade there in orange. Okay. So I've got the first one shaded. First one's done. Now let's focus on y is greater than or equal to -3. Let's highlight that. Let's highlight that in green. Now we're looking at y is greater than or equal to -3. That's the same as graphing the line y equals -3, right? And because we have a greater than or equal to symbol, we're going to use a solid line to graph y equals -3. Okay, so this is y equals -3. Okay, so we want to graph everywhere where y is greater than or equal to -3, okay? So this pink line is the line where y equals -3. We want y to be greater than or equal to -3. So we're going to go up, because y gets bigger. It gets bigger than -3 as we go up, okay? So let's shade everything above that line in green. All right. Okay. So now we're done. Our answer is going to be the intersection of these two. So it's going to be, what that means is our answer is the region where we have both colors shaded. Where we have both the orange shading and the green shading. That's our answer. So let me think of a good way. So we're going to go ahead and erase this highlighting and then re-highlight just the region where we had both colors shaded. So right here, this square right here. All right, that's my answer. Okay. So go ahead, pause, rewind, slow down, ask Mr. Miller for help if you need some help. Okay. Let's go. So intersection means, let's make a little note of this. Intersection means right, we keep the region right where both colors are shaded in. Both. Intersection, think both. Think both for intersection. For intersection, think both. Both. Okay? Union of x is greater than or equal to 2, or y is greater than or equal to -3, okay? Notice that these are the same inequalities as on the left. All right, so I'm going to graph them the exact same way. X equals 2. All right, we get our solid lines because we have x is less than or equal to 2. And then we have y equals -3. Oh, let me draw that a little better. Okay. So we're going to shade for x is greater than or less for x is less than or equal to 2, right? We shade to the left of that line. We're going to do that in orange. Everything to the left of that line. Okay. For y is greater than or equal to -3, we're going to shade everything above. This is the line. The pink line is the line where y equals -3, so we're going to shade everything above that just like we did in the last problem. Okay. All right, and then when it's a union problem, just leave it. We're just going to leave it. So union, right? For union, we keep everything where at least one of the colors is shaded. Right? So we have this region here where just the green is shaded. We keep that. We're going to leave that shaded because only one of the colors needs to be shaded there. We have this orange region where it's just orange, we keep that this time, and then we still have the region where they're both shaded in. We still keep that for union. So notice the difference, right? The parts that were only one color shaded in, we just get rid of those for the intersection. For intersection, we just get rid of the parts where one color shaded, okay? We keep the part where both colors are shaded, this upper left part here. For part B, the union of the two inequalities, that's either or, so we keep everything. We keep everything where at least one of the colors is shaded. I hope that makes at least a little sense. Again, ask Mr. Miller. Pause, rewind, okay? Email me. All right. Sorry I'm gone, but not much I can do about it, okay? So that's union. That's a union. For union, think at least one color, at least one of the colors. For intersection, think both colors. We got to shade where both colors are. For union, just think at least one. So these three parts are my answer for union, okay? Let's move on. Part C. The intersection of x minus y is less than 2 and x plus y is greater than or equal to 3. So let's start by putting both of these, getting y by itself in both of these. So we have negative y is less than or equal to 2 minus x. I just subtracted 2 from both sides. Divide both sides by negative 1. I get y. Let's flip the inequality signs. We're divided by a negative. Y is greater than negative 2 plus x. Okay? Okay. So let's go ahead and graph this right here. Okay, we'll graph it in blue. Since it's y is greater than and not greater than or equal, it's just a greater than, we got to use a dashed line. So let's switch over to that. Okay, so I'm going to graph my y-intercept, which is 0, negative 2. And then my slope is positive 1. So up 1, over 1, okay. Okay, so this is the line. Y equals negative 2 plus x. Okay. All right. That one's done. Let's do the second one here. Second one. I'm going to use pink for this. All right, let's get it y by itself. So just subtract x from both sides. We get y is greater than or equal to 3 minus x, okay? So for this one, I'm going to graph it just as if it's the line y equals 3 minus x, okay? And here, since it's a greater than or equal to symbol, since I have a greater than or equal to symbol, I'm going to use a solid pink line, okay? So that's x-intercept, or y-intercept is positive 3. Slope is negative 1. Good. All right, so I got my lines graphed. Okay, now let's think about where we're going to shade. Okay, so let's get orange highlighter out for this blue line. Right, so for y is greater than negative 2 plus x. This is the line where y equals negative 2 plus x, right? We need y to be greater than that line. So we're going to shade up above that. Okay, now let's use green highlighter and graph this pink inequality. So this pink line is the line where y equals 3 minus x, okay? We need y to be greater than that line, so we're going to shade above that line. Okay, there we go. So we're done shading. So we want to keep, we got to think which of these three regions we want to keep, okay? This is an intersection, so we need both colors shaded, both colors shaded. We want the region where both colors are shaded. That's going to be just right here in between my lines, right here, okay? To the left, we only have orange. To the right, we only have green. We want to keep this little orange and green region right here. So let's erase this shading, erase that shading, and then let's reshade the region where we had both our colors shaded, okay? So pause, rewind, okay, if you're having trouble. All right, we want to keep that region, okay? Okay, over here, a union problem, okay? 2x minus 3y is less than 6, or 2x plus y is greater than or equal to 3. Okay? So let's think about this one, okay? Let's start off by putting us in slope-intercept form, okay? So we get negative 3y is less than 6 minus 2x. Okay, divide both sides by negative 3. Got to flip our inequality symbol. We get y is greater than, right? Flip our inequality symbol. Flip the inequality symbol since I divided by negative 3. We get y is greater than negative 2 plus 2/3 x. Okay. So then we're going to graph this just as if it were the line y equals negative 2 plus 2/3 x, but we got to use a dashed line. Since it's just a greater than, it's not a greater than or equal to, it's just greater than, so we got to use a dashed line. Okay, so y-intercept there is 0, negative 2. Oh. All right. Slope is 2/3, so that's over 3 up 2. To the right 3 up 2. Okay. Okay, so here's y equals, so that's the first one. Okay, that's my line. This is the line y equals negative 2 plus 2/3 x. Okay. Then let's put that other one in pink. Using pink, let's get that in slope-intercept form. So then we're going to go ahead and graph this line using solid, right? It's greater than or equal to, so we use a solid pink line. We're going to graph it just as if it were the line y equals 3 minus 2x. So that's y-intercept of positive 3, slope of negative 2. Okay. So we're going to keep going down. Okay. Keep going. Okay. All right. Let's shade. It's time to shade. Okay, so wait. Let me label this pink line first. Oh, whoops. Label the pink line. This is y equals 3 minus 2x. Okay. So now let's shade. Let's use orange highlighter and shade my blue part here. Let's shade the blue inequality. Y equals, or y is greater than negative 2/3. Or sorry, y is greater than negative 2 plus 2/3 x, okay? So this blue line, this is the line where y equals negative 2 plus 2/3 x, but we need y to be greater than that line. So we shade above the line because y increases as we go up. So we're going to shade an orange above. All right. And then for the pink, let's use green highlighter, right? We're going to shade, we have y is greater than or equal to 3 minus 2x. This pink line is the line where y equals 3 minus 2x, but we need y to be greater than that line, than this. So we're going to shade above that line, okay? Okay. And then it's a union, right? So we just need at least one color. So just at least one color shaded, or two. You can have two, just at least one color shaded. So we're going to keep my region where it's just orange. We're going to keep my region where it's just green, and then we're going to keep my orange where my region where I shaded orange and green. So we keep all three of those. So that's it for part D. Okay. So pause, rewind, slow down, ask Mr. Miller, okay? All right, so this is where we're at so far. Let's go into these word problems. 3 word problems, okay? Let's try these out. So basically the way these are going to work, the word problems are going to give us our inequalities to graph and shade, and then we're going to do that, okay? So at a back-to-school sale at her favorite store, Laura can purchase any pair of pants for $36 and any shirt for $13. Her parents tell her she can spend at most $190 on these school clothes. How many of each can she buy? Okay? So let's let X be number of pants she buys. Number of pants she buys, right? She's going to get some awesome some jeans, I guess. I don't know what's in style these days. All right. And then Y, let Y equal the number of shirts she buys. So her amount of money she spends on pants is going to be the price of pants, which is $36, times X, the number of pants she buys. Okay. The amount of money she spends on shirts is going to be $13 times the number of shirts she buys. Okay. The total money she spends is going to be the sum of those two, the money she spends on shirts plus the money she spends on pants, and that has to be at most $190. So that means it has to be less than or equal to $190. Okay, so we have our inequality here now, and we're just going to go ahead and shade this as if it were any other inequality problem, okay? So let's put it in the slope-intercept form. How we doing? So 13y is less than or equal to 190 minus 36x. Divide by 13. All right, we divided by a positive, so we don't need to flip the inequality symbol. 190 over 13, what's that? Oof. I'm just going to leave it as 190. So that simplifies. That's just 190 over 13 still. And then 36 divided by 13. Oof, that doesn't simplify either. It's still just minus 36 over 13x, okay? So here's my inequality that I'm going to graph, okay? So I'm going to graph this just as if it were the line y equals 190 over 13 minus 36 over 13x, okay? And we're going to use a solid line because it's a less than or equal to. So let's do that. So 190 over 13, it's about equal to 14 is my y-intercept. So it's about like 4. So let's say this is the line for y equals 14. So it's about 14.6. That's going to be a y-intercept. And then our slope is negative 36 over 13, which is about 2.75. So let's just do a little sketch. Come down here, okay?
Teachers, pardon this interruption. This is just one more reminder that the flu shots are better than the NIMS. Students, if you had a paper filled out by your parents, please stop by in between class or during lunch and get your flu shots. Teachers, if you need coverage, email Sid, and they will cover your class so you can come on down. Thanks.
All right. So we're going to have this, okay? This is the line where y equals 190 over 13 minus 36 over 13, okay? And we want to shade, we need y to be less than that line. So we're going to shade below the line, okay? All right, so this is our answer just right here, okay? What this means is if we pick an ordered pair from this region, so let's say like this point right here, what is that? Let's just say it's like, I don't know, like 9, 4, right? If she buys 9 pairs of pants and 4 pairs of shirts, she'll be under budget. She'll either be at her budget of $190 or less than her budget of $190. Let's do the second one real quick. Alice is determining the seating arrangement for her big graduation party. Circular tables can seat 11 guests and rectangular tables can seat 8 guests. Together they must seat at least 195 guests, the number expected. How many of each are needed, okay? So let's be x equal number of circle tables. Let's let y equal the number of rectangle tables. Okay. All right. So we got to seat at least 195 guests. Okay. So the number of guests we're going to seat with our circle tables is going to be 11 because we can have 11 guests at a circle table times our number of circle tables. So this is the total number of guests we're going to have at circle tables. The total number of guests we're going to have at rectangle tables is going to be 8. So 8, there can be 8 guests at one rectangle table and then times the number of rectangle tables we have. So this 8y is going to be the total number of guests we're going to seat at rectangle tables. If we add these two, we get the total number of guests we're going to seat at a table. And that's got to be at least 195, right? So that's got to be greater than or equal to 195. Okay, so we're going to graph this just as if it were the line 11x plus 8y equals 195. I'm going to go ahead and leave this one in, actually, no, I'm not going to do that. Okay, so let's put this in slope-intercept form. Divide by 8. All right, we get y is greater than or equal to 195 over 8. Does that simplify at all? I don't think it does. 195 over 8 minus 11 over 8x. Okay. Graph it just as if it were the line. Y equals 195 over 8 minus 11 over 8x. So let's put that up here. Let's say this is, let's say this is the line y equals 24. So we're going to put that y-intercept up here. And then a slope of a little over negative 1. All right, draw that down here. Okay, we're going to use a solid line because it's a greater than or equal to. Okay, my y, so this is the line where y equals 195 over 8 minus 11 over 8x. We need y to be greater than this line, so we're going to shade above. We're going to shade above. Okay, that's going to be my answer. So any ordered pair we pick from here, let's say like, I don't know, 20 comma 20, right? If we get 20 of each, that'll sit everyone, okay? So unfortunately, I'm out of time. Go ahead and do the last one on your own. Ask Mr. Miller for help, okay? So watch this video, and then we'll do the 3.7 homework assignment in class together tomorrow, okay? So you guys take care.